Okay, good morning everyone and welcome to grade 7 coding. It is the 30th of, no, I'm lying. Yes, it is. It's the 30th of July and we are looking at functions in the harvester puzzle 7 to 14. For those of you that don't know me, my name is Mr. Paul de Klerk and I'm the senior phase coding teacher with STEM Digital School. I quickly want to jump into my emails here and just check. I see here, let me just quickly open this. So from Minaz, I've received an email. From Angelina, I've received an email. Awesome. So it seems like I haven't now checked all the emails. These are just the ones that are on the top of my mailbox. So that is the responses on yesterday's assessments, right? If you haven't sent them through yet, I'm going to completely final check them by the end of the weekend, okay? As with I explained to you yesterday with coding, it's not like I can take an answer sheet and just quickly run through it with a pen and make a few check marks. I have to physically take every sequence that has been created and read through it to see if it's going to work. And if I'm still uncertain, then I need to replicate that sequence on the software to see how well it runs. Okay, so it takes a little bit longer to check that, but I will, and I'll get back to you. In the meantime, tomorrow we are going to discuss all those puzzles here in our live lesson, okay? So that I can explain to you sort of the way of thinking that I would have used, and then we'll take it from there. Awesome. So if you haven't sent it yet, then basically what I'm telling you is that you still have a bit of time. Some people yesterday also sent me the links and not the actual screenshot. So I'm allocating a bit more time because our subject does not allow for you to just answer a few questions and send it back, which is an easy way of doing it. For us, you need to actually go and do the code. You need to screenshot it. You need to know how to take that screenshot and attach it to an email. There's a bunch of extra things that are involved with submitting these things for coding. So I have a bit more grace and time allowance to make sure that everyone gets a fair opportunity to participate. Right, so even if you are watching on YouTube and you'd like to participate, I don't know if the download is still available on the website, but you can check it out. Maybe it's there. If you are on YouTube and you'd like to join us in our live lessons, you can head down to the video description box below. There you will find the links leading to our registration page. So if you're a student that has access to an email address, then you can register on that and you can come and join us here in the live lessons, okay? And if you do not have access to an email address, then you can just ask a parent or a guardian to register on your behalf. And we just need an email so that you can receive an email address. So it must be an email address that you have access to, but you need to receive an email just to verify that that account belongs to a real person, okay? So if you do make it to our live lessons, there are a few ground rules that we implement just to make sure that everyone is in a safe and effective learning environment. Teaching like this is relatively new, so we're still figuring it out. The first thing is the chat box is there for me to send you resources with regards to links that we will code on that platform. You should please refrain from sending any links in the chat box, okay? If somebody comes in after I've shared a link, they can ask me and I will share it again, but I do not want to allow anybody to post links in there because I cannot control where those links lead to. Sometimes you can make a link look like a code.org link, but then when people click on it, it's actually not. So no links in the chat box, please. And the chat box is there for you to ask questions, so please do. Anything relevant to computer sciences, okay? This is not a type of subject where we can only focus on one thing and do that. I've had students asking me what they need to study if they want to become web designers, what they need to, or what jobs can they do if they know how to code and things like that. So as long as it's relevant to computer sciences, robotics, engineering, and design, that's okay. We can talk about those things, okay? In this class, I've done an entire lesson on binary code before, which doesn't have anything to do with the JavaScript that we're learning on the platform. Okay, it does, but it's not what it's all about. So yes, we're open for that type of thing. Okay, and then lastly, if you receive a private message from anyone within the chat and it wasn't from myself or from the host, please let me know. You should not be sharing your contact details with anyone through the chat. If I need your contact details, I'm going to communicate that to your parents or to the email address that you provided when you signed up for the newsletter. If we don't have your email address through that system, then we're not going to get it, and we won't be contacting you and asking you for any personal information. So please do not share any of your personal information. This is a very good rule for you using whenever you are online, okay? Don't share personal information unless it comes from an official document from the company requesting that, and that it makes sense, okay, for them to request that. And then lastly, two more actually, your videos, just keep that off. I don't have issues with that in these older grades. And then our host, I'm going to ask you to please respect the host. If I find that you're sending private messages to the host that is not in a good way or in a good manner, maybe disrespectful or swearing at the host, then I will block you from entering the classroom again, okay? And I'm very, very serious about this. I've heard that some of the hosts take a bit of a beating from students, and that is totally not fair, because without them, these lessons won't happen. So I always give them a shout out during my lessons to say thank you for the hard work that they do. They also make sure that everything gets uploaded to YouTube and all of those things, right? So please respect the host. And if you do not respect the host, then I'm going to take that as a personal insult towards me as well. So that's it. The rules are done. Let's have fun. Okay, coding is today's language of creativity. All our children deserve a chance to become creators instead of consumers of computer science. This is said by Maria Culver, and she is or was the president of Harvey Mudd College. Not only was she the president of this college, she was a massive activist for getting women into the coding sphere. So traditionally speaking, coding was a career only pursued by men, right? And this was one of the ladies that said, you know what, this isn't right. Coding is for everyone. And it is. Some of the best coders, the best program writers, Minecraft, one of the games that I'm crazy with, they have a lot of women on their staff that writes the code for those games, right? And a lot of the best coding lecturers at universities and things like that, they're female teachers. So I'm a big advocate of that. But she was basically, no, she's not the first woman that did coding. It's very difficult to know who the first person was, because there might have been people who developed programs and they didn't launch that program into the public domain. So we'll never actually know that. It's very difficult to say. But she is one of the main people who tried to advance coding under women and getting girls involved, younger girls, creating programs and things, and inviting girls to these programs, right? And she actually has an entire partnership with Microsoft, and she's on one of the executive boards there. So she did amazing things. And I love this quote that she said here, that coding is today's language of creativity, because it is a type of creativity. You are creating something new. But take myself as an example. I'm not an artist, okay? I suck at drawing pictures. I'm not good at that. But I love creating things. So there was always this sort of battle within myself. I don't have the talent to create a beautiful painted canvas or something like that. I just can't do that. But I do have the talent to create a website or a platform on the internet that people use by using coding. So for me, coding is not only a thing of logic and reason, and it works sort of by all these rules. For me, it is also a creative outlet, because it allows me to create things without needing to have any artistic talent. So for me, this quote really hit home. It is a language of creativity, and I thoroughly believe that next statement. All our children deserve a chance. All of them, all around the world, all children, in my opinion, deserve a chance to not only be the people that are sitting behind the computers, playing the games and consuming, but to create the new era or age of computer science, and in that way to shape the world, because it is through computer science that information is being shared. So it is through what is being created on computer science that the future is going to take shape accordingly. So to me, I love this quote, and I like what she stands for. So I thought I'd share it with you. Okay, perfect. Let's move on. Some terms that we need to know. Repeat blocks. These are blocks that loops a specific sequence a predetermined amount of times. Okay. So remember, we're doing revision lessons. So you might have seen some of these things before. That's okay. Remember, my belief is practice makes perfect, and it's backed by studies. So the more we practice these things, the better we will become. So any sequence of code that we place inside a repeat block is going to loop. It's going to happen over and over and over again. With the normal repeat blocks, the default repeat blocks, we set how many times we want that to happen. But that's not the only type of repeat block. Here we have a conditional repeat block. And what this says is it checks for a certain condition to be true or false to determine how the code should be executed. So instead of just repeating that sequence a set number of times, it's going to check either while something is true. So in other words, move forward while there is a path ahead. We want you to move forward. So the code is checking if it's possible the conditions are true, then the character will move forward. The other one is going to check until something happens. So while the condition is false, until it becomes true, the character is going to do something. So now we don't have to count. We don't have to set that. You can set the condition and the repeater will run as long as that condition is either true or false. Okay. Right, so we're looking at functions in Harvester, puzzle 7 to 14. If you will allow me to jump to my coding screen, I can share the link with you. What did we say? Functions with Harvester. So just before we jump into that, if you are new here or perhaps you're watching on the YouTube video, if you follow the link, and if you're on YouTube, you can type the link as it is there. You can come back to this section and you can come and do all of these lessons. This is a section I specifically created for this class under my code.org account, so you can use it and you can get yourself up to speed with us. Okay, let me just double check. I forgot puzzle 7 is what I had. Right, so from this link that I'm sharing now, if you want to get back to that screen where we just were, you just need to click on this over here. Let me just move my chat out of the way and over there. Right, if you click there, it's going to take you back to where we just were. Okay, so I'm going to start over because we've done this before and I don't want you to just copy the code. I want you to actually do it with me. Right, so if you're on YouTube, you can type this into your address bar and then you will find that you can join as well. Open it in your browser and type that in exactly with the dots and the forward slashes and the hyphens, everything as it is here, and then it'll work. Okay. Did you notice that there was a lot of repeating code in the last puzzle? We can save space by calling that code pick a long path and using a new function to call the other functions. Okay. So what we've had until this point is we've learned that we can create functions, and this is what they look like. Okay, so here when we drag this block on, we can name it something. This is a move function. Okay, usually you won't use such a long name for it, but I just want to demonstrate. And I can put actions into that. I can put loops into that. Right, I can create my entire sequence inside a function if I want to. And then I just need to call that function in the code wherever I want it to be run. And when I click run, it'll do what this function says, right? There we can see she moved as long as there's a path ahead. So now we can remove this function. Come on, you need to delete this one before you can delete that one. Okay. So they've supplied us with functions. And what they want you to learn here is that you can actually call one function inside of another one. Okay, so what we did in the previous puzzle was in puzzle 6, we created code to complete this puzzle, but we didn't have this function here. We only had those two. So we ended up using a lot of repeats in our code. We used 25 blocks to solve that one. Now we're going to call functions inside another function, call that function in the code, in the sequence, and then we're going to use less blocks. So let's first identify what each function does. We need to understand that, otherwise we will not know how to use it, okay? We need to understand how it is going to execute the code. So the first and most easiest one to identify is this one. Check square for corn. It has a conditional that says if there is corn, so if this is true, we want you to pick corn. Do this. If it is not true, it's not going to force another statement to run. It's just going to go and continue on to whatever comes next, okay? So you can check here. If we have this check square for corn, if there isn't corn, it'll just move on to move forward. It is not going to create an error, okay? But what's important to identify is also, not only is it checking for corn, it will also pick the corn if it does find it, right? So it doesn't only look to see if it's there. When it sees it's there, it does something with it. Then we have this one, get all pumpkins. So this one says, while there are pumpkins, pick pumpkins. So if we have a look at these pumpkins, there's one there, but yet this one has a question mark and that one has a question mark. So we don't know how many there are. There might be 5 under there. So what this will do is, as long as they are pumpkins, right? While there are pumpkins, as long as this condition is true, it will do this until this condition is not true anymore. So this is a plain conditional, the if, and this while is a conditional repeat. So this will only happen once, unless you place it in a repeat like we did there. But this will only happen once. This one will happen over and over and over until this condition is not true anymore. Then the code will continue on to whatever comes next, okay? So this one combines those two into a movement block. It says pick a long path. So repeat until there are pumpkins. So there's another conditional. This one is a conditional loop that says while something is there. This one is a conditional loop that says you do this until something is there. So with this, the condition of there are pumpkins is false. When she stands there, there are no pumpkins. It's false. When she stands there, no pumpkins. False, 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 false. But here, it's true. As soon as she lands on this space, there are pumpkins. So she's not going to repeat this anymore. This repeat will only run until there are pumpkins. Okay? Now, on the way there, all of these will happen. So until there are pumpkins, so while there are not pumpkins, we want you to do this. We want you to check the square for corn, and we want you to move forward, right? So that's going to move her from there to there, and it's going to help her to check for corn along the way and pick the corn once it's there. Now, after this repeat is finished, she's obviously standing on a pumpkin due to this conditional repeat having stopped being executed once she ended up on the pumpkin. Then we tell her to get all pumpkins, and there's that. Okay, so for us, we can do this in our sequence and run, and we will actually solve this entire path here. No, not the get pumpkins. Sorry, I chose the wrong one. I want to pick along the path. That's better. Let us just run it. And look at that. So let's step back for a second and think, what would this have looked like if we were not using the functions? Okay. So remove this. For us to do this, we would have had to do this here. Repeat until there are pumpkins. We would have had to say, where is that conditional? If there is corn, we want you to pick corn. And then we want you to also move forward. And then we want you to, at the end of this, we want you to, while there are pumpkins, we want you to pick that pumpkin. Now, if you run this, you'll see it's going to do the same thing, right? But look at that. So now imagine you want to use this sequence. You're going to have to recreate this sequence 3 times. That's going to be a problem. You're going to end up with a massive amount of code to use. But we can do all those same things by just calling on one function. And every other time we want to use this function, we just call the function here. We've set the functions, we've defined the functions beforehand, and now we can use them over and over again. So the only thing we really need to worry about to solve this puzzle is the movement. So after we're here, we want to obviously turn left. We want to move forward twice, 1, 2, and we want to turn left again. So now we're going to be here facing this way, and we want to harvest that. So we just call that again, pick along the path. Now when you run it, you'll see what happens. There we've called it the first time. We've done our movement. Now we're calling it the second time. And now what I see is we're going to use that function again. We're just not lined up for it yet. So we just need to add movements to line us up. Move forward and turn right. Then we call on that function again. And look at that. How easy functions are making it for us. So easy, right? Okay, so if you're happy with this, type a yes in the chat box, and then we can continue on to the next puzzle. If you understand this. If you don't, please, please, please tell me so that we can discuss it again. Okay. Right, so most of you are saying yes. I'm going to run it one more time. While it runs, check what the code is doing. And then I'm going to select continue. And it will take us to the next puzzle. We don't want to watch the video. We're going to watch the video on our own, not in class. Number 9, send, start over, yes please. Aha, there we go. So now they're making it fun for us. Functions let us do more with less work, okay? Little play on words there with letters. Create a function that sends the harvester down a square path to pick a single head of letters from the middle of each row. So we're going to create a function, and we're going to call this harvest. Now you can say if you wanted to harvest the path and just create the function to do one path, or if you wanted to harvest the entire square. Now, usually I would do only the path, but because they tell me here to do it in a square and I know the puzzles that are coming, I'm just going to code the square in here. Okay. Now, the important thing is this. If you place this here and you want to test that function, you click run, nothing's going to happen because you need to add the function to the workspace. Now you can test it. Okay, so the way that I do it when I'm doing Blockly coding is the moment I've created a function that says harvest square as an example, even before I start coding that, I drop this here just so that I can test it. I'm not necessarily going to use it in this position. I might want to move it down, but this is the way that I develop the function and I can test it. So this is a pretty easy one. Move forward, pick a letters, and move forward again. And now we've solved our first problem, which was how do we find the solution for that? Now, obviously, for this solution and that solution and that one, they're all going to be the same. So all we need to do is turn right, and we need to repeat that 4 times because it is a square. And look at that. Right, so we're still using 8 blocks because we have 1, 2, 3, 4, 5, 6, 7 blocks. So 6 blocks in our function, 7 blocks to call the function, and the when run block is number 8. It's always there. Without that block, the code cannot be triggered to run. Okay, so there we go. Can we move on to the next puzzle? Okay. Oops, that's the wrong, oh, no. Yes, that was the wrong link. Sorry. Give me a second. I'm fixing it quickly. This one's the one we want to be. Okay. So now they say, try writing your function again. Is it still helpful? How can you make it work for this puzzle? So what we're going to do is just create that function one more time. Obviously call that function here so that we can test it as we're creating it. Now I remember what this function looks like, so I'm not going to stress too much trying to figure it out. I'm just going to create it. Okay. So now I'm going to test it just to make sure that I didn't miss anything, and it's working. But there's still something that we need to do. Let's just run it again so I can show you. When she finished that first one, she's facing this way. So we can obviously see we're going to repeat this function. So we can place it in a repeat. And it's going to happen 2 times because we have 2 squares. But there's something else that we need to do. Otherwise, she's just going to do those 2 over the same square. And we receive an error there because we're telling her to pick letters, but there is no letters. Remember, we're not using a conditional here. So she will try to pick letters on that spot, whether it's there or not. So all we have to do is we need to add 1 turn. Yes, change the direction. Awesome, Amu. Thank you. We just need to add 1 turn in there. Oops. And look at that. Now look at how easy our function makes this. So you could do this as well, right? Harvest square again and call on that function twice. It's going to be the same thing. And essentially using the same amount of blocks. Because if you remove this one and you place a loop there, you are using 10 out of 10 blocks again. Okay? So that doesn't really make a difference. You can choose the way you want it to happen. Right, so are you all happy with that? Can we continue to the next one? Awesome. Thank you, thank you, thank you. Let's do. Now it's puzzle 11. Sorry, I shared the wrong link earlier. Take this out, start over. Okay, so we're going to create our function one more time. This says, this puzzle is amazing because it's in a maze. So they like playing on words with this one. Is your function still helpful for this puzzle? Well, we don't know. We just need to quickly create it again. By this time, we should be able to do it completely off of memory, except that I like to capitalize my things. Harvest square. To use a capitalization here doesn't make a difference. Let me just show you the code. It doesn't make a difference, right? That's what it looks like in line and text-based coding. You just need to make sure that when you define this and you call on it again, so let's say you're coding like this, when you define harvest square and what harvest square means, and you want to use this harvest square function again, you need to make sure that you're spelling it the same way, that you're using capital letters where you've used it when you named it the first time. Okay, so just always remember that. This name, we can call it whatever we want to. Whatever we want to, right? It's going to adapt that here. But when we want to use this function again, we must make sure that we're typing it exactly the same way. Uppercases, lower cases, underscores, everything. Okay, just a little pro tip for the future. For now, it doesn't matter too much because they give us the function over here to choose. So we place that in there. Now we create our function again very quickly. We remember this, so we don't need to make it more complicated than it already is. Lettuce, move, right. Where's the turn right? Just adjust that. This one becomes a 4. And we can already see this is the same as what we had earlier. So we might as well just do the same thing than what we did earlier. And run it. And this is now where we end up. Now we need to get lined up for this one here. Okay? So we're going to turn right. We're going to move forward once, 2 times, right? Move forward 1 times, 2 times. And I'm just going to run it so that you can see, because I need to show you something here. She's facing upwards. Now remember, within our function, we're using a turn right. So if we just call this function here, although she's in the right position, it's going to create a problem for us because she's going to try and turn right when she cannot turn right. You see there what happens. That's a big problem. So for us to have the ability to use this function, we must just make a turn left and then call the function. And now it works. So that when she turns right, she's actually going to follow the square and not try and walk into the walls. Okay? So you would have seen earlier I had this, it looked a little bit different. I just want to show that to you because it's also a way to do it. How did I do that now? Okay, function of a square, there you go. This will also work. No, then we just need to change this turn right, obviously. If we just show this to you before, just run it to there. Because we're ending on a turn right, so if we turn right now, okay, we are facing the right way. We need to turn right one more time here in order for her to look up. Where's that turn right? Again. And then we need to move forward and do this. Okay, because that last turn right is being acted out there. You can see there it runs before it goes here. Okay. So if you are going to do it the way that we did it earlier, just go back there. Come on, 11, 11, 11. If you are going to use that repeat here, you can omit one of the turn rights. Because that extra turn right is being accounted for in here. After it harvests that square, it's turning right because of this, and then it turns right immediately again because of that one running a second time. Okay? But that's why we test the code, so that it doesn't matter which way you run it, you can make sure that your movement is correct. Okay, are you happy? Can we move on to puzzle number 12? Perfect. So we're going to say that we are ready. We're not afraid of a challenge. Just start this over. Use everything that you've learned so far to solve this puzzle in 19 blocks or less. So for us to do that, I need to share the link with you. That's the first step. Make sure it leads to the right one. Yes, it does. Now we just need to make sure that we understand these functions again. If we don't understand them, we cannot use them here. So we start with the easiest ones. Check square for corn. If there is corn, pick corn. So we understand this one. We've used it multiple times. This one, get all the pumpkins. While there are pumpkins, pick pumpkins. This one we understand. Pick along a path is the same as the one that we had earlier. Repeat until there are pumpkins. While you are not on a pumpkin, we want you to check for corn and move. And then as soon as you are on a pumpkin, this repeat or stop, then we want you to get all pumpkins. So our best bet is to say, okay, let's just run this and see what's going to happen. Perfect, that works beautifully. But we need to turn right and we need to repeat this 4 times. Because there are 4 paths here. So now we can run it and test that. There's the second one, the third one, and the fourth one. Now you can see when that last turn right runs, she is facing this way. So we need to place one more turn right to make a move down here. And then we are going to repeat all of this a second time. And let's see if that works. So now we have a nested loop when we have a loop inside a loop. And look at that. Right, so what I want to draw your attention to here is, what do I want to say now? Oh, the 2 different ways that you can do this, right? This is the first way. And then after that, you have to just turn right again. Oh, no, we are turning right. And then we can enter our function again, pick along the path, and we can loop that again 4 times. But the problem that we have in trying to do it this way, we don't have any more turns that we can use. We've run out of them. So we don't have a turn to place in there, which means that we're only going to harvest until we reach this point here. Run, please. Okay, so you can check now. She's into that last repeat now. But now it's trying to do this 4 times and she cannot move anymore and she cannot turn because we don't have a turn. So to counter that, we just repeat this because we are already using our turn over there and another one over there. So if we have a turn or a block and we're limited to how many times we can use that, we can either create a function with that in and call the function each time, or we can check where the code is repeating and just create a loop. Right, are you happy with that one? Awesome. Okay, puzzle 13. We're going to fly through this one, okay? It looks complicated, but it's actually very easy. To make it easier for us, we're going to use comments. Okay, and we're going to say harvest the steps, right? So now we first need to check all of these. Now, in my opinion, I don't really like these ones. I don't want to use them for this here. So I'm going to create my own function for the steps, okay? And these ones I'm then going to use for over there where the corner is at. So I'm going to create a function and we can call that harvest steps as well, right? The comment is just there for you to see what the code is doing, right? You don't need to use that because we're labeling the function. It's going to be up to you. But I want to be able to test this, so I'm going to place that there. So I can see I have to move forward. I have to turn right. I have to move forward again. And I have to turn left. And if I run it, we can see the movement is good. But we need to do it twice, so I'm going to repeat that 2 times. If we run it again, you'll see that it works beautifully. The only hassle I have now is we are not collecting the letters. So for that, I'm going to use a while there is letters loop. Now you can place it either after the turn left or before, it doesn't matter. And I want you to pick the letters. And I'll explain to you why that doesn't matter in a second. You need to remember that it is going to follow the sequence though. But over here, we are harvesting that before we turn. And if we do it this way, we are turning and then we harvest. Okay. So it's important to note that the sequence will still run, but you are still on the same place on the map or on the play area. So you can then use either one of them. Okay. So now we're here, we lined up this way. We want to collect all of that. So we can see there is a pick along the path function here. Let's run that just to make sure that it does what we think it's going to do. And it does do that. But we have to turn there. So what I'm going to do is say turn left. And then this is happening 1, 2, 3, 4 times. So I'm going to loop this 4 times. Now if we run it, you'll see. Why are you not allowing me to turn left here? That's very strange. Oh, you know what? This repeat until there are pumpkins. We need to change that. We need to change this one to another loop that says while there is a path ahead. Because there are no pumpkins here. So it's going to try and keep on repeating as long as it possibly can. So now we're telling it to turn when there is a path, as soon as the path is finished. Right, there we go. Now it's working. Perfect. So then we can actually place this in here. Now, what I want you to notice there is, as soon as I realized there was a problem, I took the sequence out of the loop and tested it. Now I'm putting it back into the loop. It's much easier to find the problems when they are not in a repeat block or not in a loop. When they are in a loop, it's much more difficult to identify where the problem is. When we get there, we're facing the right way, so we only need to call our function that we've just created. And look at that. Awesome. So this one is going to be your homework. I just want to quickly see what it looks like. I did it. Oh, this one's awesome. You just need to answer the questions here. Okay. This is very, very good practice. So what I want you to do is send me an email that shows the answer. I'm just going to jump back to my screen because you can obviously now see that there. Okay. Come on. There we go. Right. So take that, go and look at that code and then try to identify what the answer is. And then you can just email me with that answer. It would be awesome. So tomorrow we are going to look at the assessment review. We're going to look at each one of these puzzles that you had in your assessment. We're going to discuss them, and I will finish checking and grading your assessments by the end of the weekend. So on Monday, you will definitely have your results. If I'm done with it before that, I will email you the results as I finish with them. Okay? So we're going to find out how did it go yesterday. You are coding ninjas. That's why I have that little ninja sword there. Awesome. In the meantime, homework you can send to me here, questions you can send to me here. You can find us on Facebook, Instagram, Twitter, searching for Africa Teen Geeks. We are on YouTube as well. So go ahead and go and subscribe and hit a few likes there. It'll definitely help our channel out so that we can reach more students across the country as things are going a little bit crazy with the schools. Okay. Thank you so much for being here, and I can't wait to see you tomorrow. Bye.